All right, let's look at the homework 15.5, problem number 9. All right, so we have a joint density function here, f of x comma y, and we have this unknown constant c, and times x times quantity 1 plus y. And this is between 0 and 4, and y is 0 and 6, and it's 0 otherwise. All right, so let's we have to make sure find the value of c so that this is actually the joint density function. All right, so I'm going to just define f first. F of x comma y, right, colon equals, right, it's going to be c times x times and 1 plus y, right? Then hit enter. Right, we have that. Right, then what we want to do is we want to integrate over the entire xy plane, but we have this function only between x is between 0 and 4, and y is between 0 and 6. Right, so let's evaluate the integral. So integral, and we take this function f of x comma y. Alright, let's do it with respect to x first. Alright, x is going from 0 to 4. Alright, then we hit enter. Alright, so we got that. Then we integrate. Then with the same function, so result, take the result from line 2. And the variable this time is y. And y is going from 0 to 6. Alright, then hit enter. Alright. So it looks like we got 162c, right? But we know that this has to be equal to 1. So we know that the c is going to be 1 over 192, right? So let's type in 1 over 192, right? So let's check the answer first. Submit for testing. Alright, it came back and looks like we got part A correctly. Alright, so since we found that the C is 1 over 192, I'm going to go ahead and plug it in right here. 1 over 192 and hit enter. And so that gives you 1. Alright, so let's look at the probability where x is less than 1 and y is less than 1. Alright. So here, all you have to change is x is between 0 and 1, and hit enter. And y is between 0 and 1 as well. Alright, so it came out to be 1 over 256. So I'm going to put the 1 over 256. Right? Right, so let's check the answer. Submit for testing. Alright, it came back and it looks like we got the part B correctly. Alright, so let's look at part C. Alright, so in order to do part C, we have to kind of draw the picture of the region so that we integrate over the correct region. Alright, so I'm going to bring up a sketchbook. Alright, so in order to sketch the corresponding region, so we have, so here is the y-axis. I'm going to use capital Y there, and then I'm going to use the x-axis here. Right. Then it says that so I'm going to look at this equation here. Right, and I'm going to solve for maybe let's solve for x, because we're going to do it with respect to x first. So I'm going to subtract this of here. I'm going to subtract y from there. So you can see that x is going to be less than or equal to 1 minus y. Right? So so if you look at the borderline, so the y-intercept is going to be, actually x-intercept is going to be 1, and so it's going to go through here. Alright, and when x is 0, y is going to be 1, so it's going to go through here too. So this is going to be the straight line for the borderline, right? Then we are looking at smaller, so we are talking about region, this triangular region. All right, so if you want to set up an integral, right? So we know that here, this equation here is x is equal to, so x is equal to 1 minus y, and this equation here is x equals 0, right? So what we want to do is we want to integrate from x equals 0 to x equals 1 minus y, right? So let's do that. Maybe I'll bring that up. Right, so the integral is going to go from, right, from 0 to 1 minus y, right? Then, so hit enter. Right, then x is gonna, y is gonna go from 0 to 1. So it's actually already there. So 0 to 1, right? And so that's going to be the probability. So I'm going to just put that up there here, right? So probability is 5 over, right? So it's a yucky number, 4,608, right? So let's submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.